Okay, all right. Okay. Hello, remote audience and internal audience. Hey, we're going to kick this off now. I think we've done one format similar to this before. Our presenter tonight will be presenting remotely. And so we'll do our typical intro stuff here. We got a couple announcements to make. And then we will be internally as a group watching presenter on screen. And then, of course, everyone remote, and they don't really know the difference. So we got the dual audience thing going on. It's always fun. So I'm going to switch over here real quick. Typical announcements. I feel like all the faces in here are familiar tonight. Any first-timers by chance? First timer. All right, sweet. Welcome. My name's Mike Bates. I'm the president of Springfield Devs, and we've been getting rolling pretty good back from the COVID days, but things are starting to level out pretty good, but occasionally we still have some hiccups, so if that happens tonight, just bear with us. If you've been here before, the remote audience, you talk about this site, so I'm going to do it one more time. I'll start to keep it more and more brief. But sgf.dev is our website. We're really pushing to get the member profiles on there filled out. So this is steadily growing. We got about 40 signed up in there now, but in our meetup, we've got about 700 people. So we're going to increasingly make this a more aggressive push to get signups in here. And in conjunction with trying to get the member profiles in here, the other side of the coin has been getting companies involved, so sponsors of the group. And so we list our sponsors right up front here. So these companies have all come on and decided to help out the group, help out the community. And one of the features that we've been working on getting live is finally out there, at least the first iteration of that. And that is the jobs section of the site. So previously, if you clicked on jobs, you saw a coming soon message. And so it's finally out there. This is going to grow and become a lot more feature rich. We just really had to lay the groundwork to get this going. And so we've got WWT, Worldwide Tech, with a couple listings in here. I posted these manually on my own and had Ben, who posted them in the Discord group. That's where I took those from. So I told him to check them out, make sure everything was accurate. So hopefully they are. Ben, sorry if I got anything wrong on this. But pretty soon this will be hopefully a lot more listings in here. And the idea is that you'll be able to filter on key things like skill sets, kind of beginner, senior, mid-level type things, location, remote, is it in person, what's the deal? All that stuff, right? And then going into, of course, the job details, list everything. One of the things that we're going to push really hard for, and we'll see how this goes, is transparency when it comes to compensation. So a lot of times you'll see like no detail, right? And just like depends on qualifications and such. And I get that, but I feel like we can try and push maybe a little hard here for a bit more of an intimate job listing and a very qualified group here to get a little bit more transparency. And it seems like Worldwide's pretty good about it. So like that one was straight up listed that in the job description. And then the other one didn't say as much, but they are competitive. So yeah, so jobs, hopefully that'll become a lot more full here pretty quick. And there'll be the detail page will get fleshed out and have a lot more information on there, styles and company information and such. So that's kind of the big update for this month on the website. I suspect by next dev night, this will be a lot more rich. And as a member on the site, you have the ability to set your status of work. So if you're looking for full-time work, part-time work, contract stuff, or not at all, and then if you elect to have the ability for companies to contact you, they'll be able to contact you right through the site. They'll have to be authenticated so you won't get spammed or anything. Hopefully not from unknown sources. At least we'll know who the source is because they will be authenticated. And they'll be able to reach out to you directly. You'll receive that communication, through the website, so they won't necessarily have your email address or anything until you respond back to them. So that's kind of the big thing we're working on here. The other announcement, which I wish I had something more formal, but got tied up and didn't do it in time, but we have open board positions. Springfield devs. And so we've got right now, I believe, 2 open board seats that are general board seats. We meet, we've kind of reduced it just because there's not been a whole lot going on. So we've reduced our formal board meetings to about once a quarter is what we're doing now. We were meeting every month, and then it just got to the point where, like, man, there's just not much going on. So we limited it to once a quarter. But we also have committees, and you do not have to be on the board to be part of a committee. So we've got an events committee that handles things like, pizza and topics, and Tiffany's going to talk about that here in a little bit. We've got the board seats, and again, you don't have to be on the board to be part of that committee. So since we shortened our board meetings to once a quarter, we're kind of putting a lot more of the emphasis on the committee meetings, because that's really where most of the action's happening, the website committee kind of stuff. So if you're interested, I'm going to get the link up on the site. Tiffany, if you can, go ahead and slap that in Discord too. We've got a form to fill out. And this doesn't necessarily have to be a right now thing, because the other board positions, so like my position of president, and we've got the vice president, treasurer, and secretary. So those positions will be coming to an expiration, I think, within about the next year. So those will start to lapse, and new leadership positions in that. But then the general board seats, they cycle. Don't quote me, I believe it's every year. I could be off on that. But those cycle. And so we've got 2 right now we're going to be looking to fill. So if you've got interest, go ahead and fill that form out. And we'll push that on all social media and everything too here in the coming days. We want to have enough time for the entire community to get a chance to put their name in the hat for that. So if that's something that interests you, watch the website, watch Discord, watch social medias, watch Meetup stuff. You'll see it if you keep an eye out. I think that's everything I had. Tiffany, are you good to talk on your stuff? Yeah. Oh, yeah, over to Twitch. Yep. So I'm gonna do this number.
I won't start talking until I know you've got us all set up.
You're ready to rock.
All right, cool. Well, hey everyone. Tiffany Ford, staying home today, not feeling so great, but head of the party planning committee, right? So Mike talked a little bit about the events committee, and one of the things that we really wanted to know was, do you want a holiday party? And so we have a poll up in our Slido. So if you would be ever so kind as to join our Slido with the information you see there on the screen and fill out our survey. We have a couple of questions about just the party in general. Like, do we even want one? And if we do, then what are the kinds of things that we would like to see at the party? So, are you interested in a holiday party instead of a December meeting? Because normally we don't have a December meeting because we do a holiday party. But maybe we're interested in a party remotely if we're not wanting to do an in-person. And then there's another question in there about food. Are we interested in going out somewhere where food could be ordered? Are we interested in doing like a potluck? So we're also going to be using the Slido for the speaker Q&A tonight. So please join and do the poll questions for us, but as well, you'll want to leave that around, maybe up in the background in case you want to submit any questions to that Q&A portion during the presentation. Mike also mentioned that you don't have to be on the board to be part of a committee. So if you're interested in joining a committee, the events committee would love to have you. You're welcome to come to our meetings, kind of see what our process is like as far as how do we set up like this kind of environment, these streaming environments. How do we want to move forward with different types of events? How do we find speakers? So anyone who wants to be a part of that, our next meeting is going to be Monday the 18th at 5:30 p.m. in the Discord. And so, speaking of the Discord, we feel like we have a really great tech community, and we would love to have everyone in the Discord. And if you're not familiar with Discord, it's a free chat platform. You can discuss. We have various topical channels. You can share info. You can even share files. It supports voice and video. And that's really kind of, how we have our committee meetings. It's a lot of how we do our remote streaming and things right now. So if you're hiring, we have a great place on the website to put that information now. But there's also a place to put freelance gigs, a place where you can network with others, really get plugged in with happenings in the group, where you can get connected to those committees, really find out what's involved. And so that information, it's on the website, it's on the Twitch layout, put it in chat. There's lots of places to find our Discord, but everyone is welcome to come and hang out in there. So I think that is all that I have. If you do have any questions about the events committee or just anything in general feedback-wise that you want to tell us about events, about holiday parties, anything like that, you're welcome to stop by the events committee channel in the Discord and just drop that information, or you can DM me in Discord if you don't want that information to be public. I'm happy to chat with you about the events. So I am going to turn it over to Chris, who's going to give us our presentation tonight. Again, we're doing questions in the Slido, and we have that Slido information on the Twitch layout, so you can join that. If you do have a question, that's where he's going to be looking for those. So we'll get switched over here.
All right. Hey, everybody. My name is Christopher Baunach. I am a front-end software engineer at Reach Platform, and tonight I'm going to be giving a introduction to the Reach language. So what is Reach? Reach is a language for building decentralized applications. A decentralized application, or dApp, is one that runs on a decentralized computing system, or chain. Ethereum is one example of a decentralized computing system and is built up of a network of around 3,000 plus nodes around the world that work in concert to compute the logic of these dApps. In addition to Ethereum, there are other chains like Algorand, Conflux, etc. Reach is primarily an immutable functional language, so if you've dealt with Scala or OCaml or Haskell, you'll start to see some patterns kind of carry over into Reach. It does have some elements of mutability, but we won't be covering all of those in this talk today. I like to say Reach uses a gradient of the JavaScript syntax. Starting out, a lot of what you write will look like JavaScript, creating functions, defining constants, chaining functions, etc. But as you kind of become more accustomed with the Reach language and start to use the more Reach-specific functionality, it'll start to take on a syntax of its own. Also, Reach will probably be very different starting out than what you are used to. Whether you are a front-end engineer, back-end engineer, or even full-stack engineer, coding with Reach is probably going to be quite a change of pace from what you code on a day-to-day basis. Nonetheless, after a while, you'll get used to the new structure and patterns that you need to use to code with Reach. So why does Reach exist? Currently in blockchain development, there's another number of issues, and those issues are kind of what Reach tries to address. Starting out, we have the different hardware, different languages problem. Different chains use different languages. So if I want to deploy a dApp on Ethereum and Algorand, I have to write the dApp in Solidity for Ethereum and then write it again in Teal for Algorand. This is kind of comparable to the old iOS and Android issue of you have one app that you want to release on both stores, so you have to write it in Swift for iOS and then Java for Android. DApp development also isn't easy. Due to how complex and time-consuming some aspects of dApp development are, there's a high dropout rate of people entering the scene. Despite decentralized applications being a multi-billion-dollar field, there's only a handful of developers compared to other subfields in software. This difficulty problem is part of the reason for that situation. Errors are also a bit different on chains. Imagine forgetting to have a button call a function, someone clicks that button, and the whole application goes down. Instead of being able to push a fix and redeploy, you need to create a whole new environment with the fix included and point your users in the direction of that new environment. And that's just one example of how serious a bug in a dApp can be. Auditing is another big thing. Because of just how dangerous errors are, dApp programmers hand over the completed products to auditing firms to ensure that the dApp is bug-free. However, this audit costs a lot of time and money, plus they can't fully ensure that the dApp is bug-free. Also, once the audit is finished, you then need to go clean up the found bugs. So how does Reach solve these things? To start with, it has this kind of one language, many chains concept at play. And this allows you to create one dApp that works on multiple chains. Do I want to create a dApp that works on Ethereum, Algorand, and Conflux? Done. I just compile my auction dApp and it can now be deployed on each chain. Simplification is another aspect. Reach condenses down a lot of the complexity and time-consuming aspects of dApp development. Do I want to test how that auction dApp works with the front end I made for it? I run one cli command and to stand up a devnet for Algorand and run a yarn command to set up my front end, and I can start testing. Please. Reach also has a built-in verification engine. I like to think of this as a program that automatically generates unit tests for your code on compile, but what it's actually doing is applying a variety of theorems that verify your dApp is airtight. Can the user enter in an index for an array that is outside its bounds? How about a value that triggers an overflow in one of your integers? What about a tokens getting locked away in the dApp? No, no, and no. The verification engine will find all three of those errors and more and refuse to compile the dApp. So how does Reach work in practice? Well, let me show you. So we have just an empty folder right here, and we are going to install Reach. Just going to clear that away real quick. Actually, we'll just start a new one. To do that, we'll head over to Google, search install Reach, and this will bring us to their documentation. Now, starting out, if you have like Mac or Linux, it's a little bit easier to do the initial setup steps. Windows is a bit more complex, but they have a handy little YouTube tutorial over there. But for now, since I already have the initial setup stuff done, I'm just going to grab this curl command, head back, open up a WSL terminal, paste that in there, and we have Reach. So we'll just run that Reach version command, verify it's in, and it is. Okay, so we'll be creating a simple dApp from the Reach docs. I find it best to explain this with kind of an analogy. So there's a table with two chairs, and at those two chairs, one person is going to sit down, her name is Alice, and then another person is going to sit down, their name is Bob. In front of each of their spaces, there is a box marked front end, and in the middle of the table, there is a box marked contract. And then there is a witness standing nearby. And this dApp is going to be Alice selling a trade secret and Bob buying that trade secret. But to start with, let's bring in a boilerplate with Reach in it. So that'll bring in these MJS and RSH files. Going forward, you'll hear me refer to contract and front end. So in those cases, the RSH file is the contract and the MJS file is the front end. Kind of this whole thing is the dApp. Which, now that we're at that point, let's dive into this RSH file. Give it some JavaScript highlighting. So here is a Reach contract. And up here at the top, we have the version number, and then this reach.app function area is where we're going to have the bulk of our business logic for this for this contract. So we have those, one of the prior participants mentioned Alice, and then Bob, and then really take note of this interact interface comment here, because that's going to be pretty important. I like to think of this as kind of the actions that specify what the participant is able to do. But it can also be other things up to and including how the front end is able to communicate data back to the contract. Speaking of the front end, let's hop over there real quick. So this is the basic boilerplate front end, and this is just going to allow us to kind of test our dApp. So we have accounts being made for Alice and Bob, and then Alice deploying the backend, in this case, deploying the contract, and then Bob attaching to that backend or contract. Then we have kind of the front end of those interact interfaces. And now we can start building the contract. So we're going to head over there. And it has regressed to its plain text ways. So we're going to turn it back to JavaScript highlighting. And let's begin with working on Alice's interact interface. So up here, we're going to define a constant, Alice's interacts. And Alice is going to have a request, which is going to be that amount that she wants for this trade secret. And then under info, she's going to have a byte string, and that is going to be the secret. So we'll just drop that in there. And then we'll have Bob's interacts. And Bob will have a want function, which is how he will relay the request that Alice has to the front end. But he won't expect anything back from the front end. And then he will have a got function, which will relay the secret to the front end. And that also won't expect anything back from the front end. Okay, so we will just drop that in here. And then we can start working on our program. So at the start of this, Alice will kind of reach into that front end box, take out that request, hold it up so that Bob can see it. And then that'll be the kind of the end of the first part of our program. And so how she's going to do that is Alice is going to call this only function. And getting the envelope out of the front end is going to look like this, interact.request. So interact interfaced, interact.request getting the interacts interface request. And in reach, data coming from the front end is private by default. So Alice is going to need to declassify that information. And then to make it available to the other members of the contract, she is going to publish it. And then that witness standing nearby will take note of this. Okay, then in order, we could run our first test with reach compile to compile the contract. And takes a little bit, but then here we can see the verification engine in action, it running our contract through a series of 7 theorems and not finding any failures. So in that regard, we can know that our contract is airtight. So we'll head on to the next step, which will be Bob. Now that he's seen the requests, Alice has held up the request and made it public, he can now decide to pay that request. And before he does that, he is going to relay that requested amount to the front end with that want function from earlier. And then he is going to pay that amount using dApp. And then once again, the witness is going to take note of all of these. Okay, now we can compile the contract again. And here we can kind of see it catching an error in action. So this is a bit of what an example of one verification failure looks like. It checked 10 theorems, 4 failed, and 3 were omitted because they were repeats. So this verification was attempting to assert, and we can assume that it was attempting to assert this balance 0 at exit kind of theorem. And so what this is Alice is requesting amount and Bob is paying that amount into the contract box. But the contract can't finish with tokens still in that contract box. And so we need to make sure that this contract does not finish with tokens still in that box. And we're going to solve that by adding an additional step, which is going to be Alice announcing that secret. And then since there is proof that Alice has announced that secret, that amount in the contract box can be handed over to Alice and the contract shouldn't fail anymore. This is very important to have because pre-reach in blockchain languages didn't have a lot of defenses against this, so you could accidentally lock a large amount of tokens in a contract, unintentionally burning money, essentially. And then Alice is going to publish that secret. And the contract is going to transfer its balance that's in that box over to Alice. And then once again, the witness is going to take note of these things. So now we'll compile again and see whether that fixed the issue. And we can see that it did. We're now checking 17 theorems and there were no failures because the requested amount is being paid into the contract box, but before the contract ends, it's being taken out of that box through this transfer balance to Alice. So that doesn't end the contract there, though. We still need to have Bob notify his front end of what the secret is. So we're going to have another only, and we are going to have an interact.got from that interact interface, and we're going to send it the secret. And then, since there isn't anything to publish or pay or transfer, we will just exit the contract. So there we have it. We have just completed our first reach contract. But we haven't completed our first reach dApp. So let's head over to the front end and wrap that up. And while I'm heading over there, I should probably note this build folder. So this build folder is what gets built on compile. The reach contract is really an abstract blockchains. And so it's going to, on compile, build this index.main.mjs, which is the actual contract code that the front end will deal with. And it's the contract code that's going to allow it to work with multiple chains. But getting back to this front end over here, we really just need to build out the front end interact interfaces. So we're going to start with Alice's interacts. And we have that request. And we'll send back 5. Now, sadly, we can't just send back 5 as a number. The contract views numbers differently since it deals in unsigned integers. 5 is actually represented by 5 and a whole ton of zeros that are representing decimal places. However, we don't need to know that amount of decimal places since this handy standard library function, parse currency, takes care of all of that for us. And then for info, what would be a trade secret? Invest in international steel. Okay. Now we could work on Bob's interacts. Bob had that want function by which he relayed the requested amount to the front end. And so we will say Alice wants, and much like before with the parse currency, when we get an amount from the backend, we need to also format it back into human readable numbers. So we are going to use another standard library function, format currency. Amount. And Alice wants 5 tokens for the trade secret. Okay. And then there's that got function. That'll be the secret being sent to the front end. So we will console.log Alice's trade secret is secret. And then we'll head down here and we will drop that in. Okay, so now we can run the full-fledged dApp and we will use reach.run, /reach run for that. And this will stand up an Ethereum node to run that build file on. And there we can see it. Alice requested 5 tokens for the trade secret. Bob paid that amount, and Alice's trade secret was made public, and that is invest in international steel. So we have just created our first reach dApp. It's pretty simple, but it's a dApp nonetheless. Now, all of you probably noticed a bit of a pattern going on in this RSH file with these steps kind of being somewhat similar to each other. So let's delve into that pattern and kind of understand the terms and definitions that make up what it is. So what do I mean on this slide by computation flow in reach dApps? We're all probably familiar with a few types of computation flow. One of those would be kind of functions. So say we had a make pasta function and that broke down into a boil water function and then a add pasta function. And then those sub functions broke down into more functions. And if we had like a bird's eye view of this flow of functions, we would start to see a bit of a directed graph. Now, Reach has this computation flow represented by the functions, but it also has an additional one, and that is that pattern we were seeing, and it looks something like this. So the Reach contract starts out with an initial step. It then goes into a directed graph of additional steps, and then each step is broken down into these 3 segments over here: local steps, consensus transfer, and then consensus steps. So let's delve a bit into what make up those 3 segments. We'll start with local steps. A reach local step occurs in the body of only or each statements. It represents the actions taken by a single participant in an application. So we didn't cover the each statement this time, but we will in future talks. It's interesting. Local steps are plural because there can be many of them. So also not covered in this talk is that we saw those only segments showing up in each step. There could have been multiple of those per chunk of code, but we really only needed one in this step. Some of the ones we saw were interact. This allowed a local step to interact with the variables or function of the participant interface. So Alice getting the request data from the front end, or Bob using a function to relay data to the front end. We also dealt with declassify, that made data brought in from the front end public. So Alice being able to get that data from the front end and make it public so that the rest of the contract can see it. Then there were consensus transfers. Independent steps are punctuated by consensus transfers, which cause all the participants to come together and agree on the computation, which is called a consensus step. So think of these as kind of voting day, in that we're all coming together to vote on laws and candidates. Well, the event of everyone coming together and voting is somewhat similar to a consensus transfer. Now, a consensus transfer is a single chain of functions in the step. That's underlined and has an asterisk because it's a bit more complicated than that, but for now we can understand it as that. And then when you get it further into reach, you'll kind of build up a better understanding of what it is and what it entails. Now, in our just demo dApp, we saw publish and pay. So those were only really single link chains. And publish made data available to other participants in the contract. So Alice publishing the request so that Bob can see what the request is. And then pay was also relevant because we had the relaying of network tokens from a participant to a different address, Bob sending network tokens to that contract box from his wallet. Then we have consensus steps. A reach consensus step occurs in the continuation of a consensus transfer statement. It represents the actions taken by the consensus network contract of an application. Now, kind of to continue that voting day analogy, much in the same way as a consensus transfer was everyone coming together to vote, a consensus step could be thought of as the kind of actions taken on voting day. Now, there can be multiple consensus steps, but it should be understood that they will be in the form of a graph instead of a list. So local steps could be thought of as a list of local steps, but when we get to consensus steps, we should be thinking of those as a graph. One that we saw was transfer, which transfers network tokens to an address from the contract. It must be paired with a .to, and it may only occur within a consensus step. Commit, we saw a lot more of, that ends the current consensus step and allows more local steps. So that was kind of ending the recurring chunks of code. So now that we've seen an overview application, kind of how computation flows in a reach contract and these three segments that are making up the steps, let's combine all of that into a unified piece. And that unified piece will look something like this. So we have our directed graph on the left side, starting with the initial step, and then going through the various steps. And then each of those steps breaking down into the local steps, the consensus transfer, and the consensus steps. And then those breaking down in turn into the pieces of code that they kind of map to. So to go way, way back to that analogy at the beginning of the table, let's kind of finish that analogy. So you have the table where Alice and Bob sit, and they have their front end boxes in front of them, and then the contract box in the middle of the table, and the witness nearby. Alice is going to reach into the front end box, take out a letter, unpackage that letter, and hold it up, and that is going to be the request. And then the witness will take notes of that. Then Bob, seeing the request, will write it down on a piece of paper, put it into the front end box, pay the requested amount into the contract box, and then once again, the witness will take notes. That now Alice will reach into the front end box again, this time taking out a different letter, unpackaging it, holding it up, and that is the secret. Now the contract box will empty out over to Alice, and she'll get what she asked for in return for the now published secret. And then once again, the witness will take notes of all of this. Now the last step is Bob writing down that secret and putting it in the front end box, and then the deal is over. So we could kind of see how that analogy is mapping to this code, and that Alice is interacting with the front end to get the request, to get that letter, and then she's opening it, declassifying it, and then holding it up, which is the publishing of it. And then the corresponding steps that follow. Okay, so I think that just about wraps up our introduction to the Reach language. So we went over a summary of the Reach language and what it solves, an example of writing a basic Reach dApp, the flow of computation in Reach contracts, the stages of a Reach chunk or step, local steps, consensus transfer, and consensus steps, and then how the flow, stages, and example all tie together in one. Okay, so question time. I'd love to answer any questions any of you have about this. While you get those entered into Slido, I had a few that I thought might come up, and I will answer them. How much do I need to know about blockchain or crypto to start using Reach? Practically nothing. Because Reach is that abstraction of blockchain and crypto, you could learn Reach, and with the knowledge you're getting from Reach, it'll be easier to learn blockchain and crypto. What does the job market look like for blockchain developers? So that was kind of addressed way back at the beginning in that the field is pretty developer starved. But there are blockchain jobs out there. There are companies that aggregate them so that they're easier to find. There's freelance work, there's competitions. If you're looking to get into the field, I'd recommend you start with doing a competition or a few competitions. Because of that developer starvation thing, some of these competitions will essentially throw money at you. Like, you don't even have to place on the leaderboards of the competition. You get something functional finished, you write an article about it, or you make a video about it, and you'll probably be walking away with a reward. This way, kind of taking this competition route, this allows you to test the waters of the field, see if it's right for you, and get paid for your time testing it out. Where can I learn more about Reach? So Reach has a website, reach.sh, and there you'll find links to the docs, links to the Discord, their YouTube channel, their Twitter. Also, tomorrow I will post kind of a Reach starter guide in the general channel for any of you who are interested. And yeah, what can you build with Reach? So this time around, that overview application was quite simplistic. But if you go into those docs mentioned, you'll find a workshop page. And this includes examples of tons of different things you can build with Reach. You could build loan systems, you can build Kickstarter systems. NFTs are getting pretty popular, so there's examples of dApps you can make that deal with NFTs. There's just a lot out there. Why are there almost no Stack Overflow questions about Reach? So Reach is currently answering the bulk of its questions on its Discord. There is plans to migrate to Stack Overflow. However, the team kind of has to balance that with all the other things it has to work on. So one day. And you guys want to ask any questions? I'll sit tight for 2 minutes, and then none roll in. We'll go on to the rest of the talk, which is like one slide, and then that's it.
Yo, hey, dude. Thanks for the talk. What's something, I guess, like that you've built with Reach to solve a business need?
So I haven't used it to solve a business need yet, but two of the things that I have been have built were for competitions, and those were a basic kind of auction. And the second one was just a game. It was if any of you have ever played Moncala, it was Moncala on the blockchain. Now, as I'm currently employed at the company, I am working more on a business-based decision, and that is a decentralized exchange that my company is building for one of their future clients. I guess I shouldn't say future client. It's something we're building. All right. Well, if there are no more questions, I will wrap up the show. Future talks. So this was, is there another question, Mike? No, there isn't. Okay. Future talks. This was part one of a series. The two upcoming ones will be crucial Reach concepts. This will cover some concepts that are very important to developing Reach dApps. All of the material in this talk, however, is covered in the Reach tutorial in the doc, so feel free to get the jump on this one and take that tutorial. Reach front-end integration is going to be the last one. This will cover how to integrate a Reach dApp into a React front-end. However, I'm open to using any framework, so whenever the time of this talk rolls around, I'll post a poll on the Discord and let you all decide whether I use React or Vue or whatever. Also, the events committee needs more speakers for talks. So whether you're an extrovert who wants to present in person, or you're like me who is more of an introvert, didn't do too well in public speaking, who wants to essentially get on a Discord call and talk for 30 minutes to an hour, then that works too. So yeah, if you just want to join the Discord and reach out to Tiffany Ford, she'll get you on your way to presenting your first talk. And I think that about wraps it up. Thanks, everybody. It's been great giving this talk for all of you, and have a great week.